Good morning, everybody. In today's class, we will discuss about classification of bridge. Bridges can be classified into various types depending upon the following factors. First, materials used for construction. Under this category, bridges may be classified as timber bridges, masonry bridges, steel bridges, reinforcement cement concrete bridges, pre-stressed bridges, and composite bridges. Next come to alignment. Under this, the bridge can be classified as straight or a skew bridge. Next come to location of bridge floor. Under this category, bridge can be classified as deck, semi-through or through bridges. Next come to purpose. Under this, the bridge can be classified as aqueduct, viaduct, highway bridge, railway bridge, and footbridge. Next come to nature of superstructure action. Under this, the bridge may be classified as portal frame bridges, truss bridges, balanced cantilever bridges, and suspension bridges. Next come to life. Under this, the bridges may be classified as permanent or temporary bridges. These permanent and temporary types of bridges are further classified as in given chart 2 of IRC. Next come to loading. Road, bridges and culvert have been classified by Indian Road Congress into class AA, class A and class B bridges according to the loading they are designed to carry. Next come to flexible or movable. Flexible or movable. For negative channels where permanent and sufficient clear waterway cannot be provided, for the following movable bridges are used: swing bridges, bicycle bridges, and lift bridges. Next come to span length. Under this category, the bridge can be classified as culvert span less than 8 meter. Next come to minor bridges span between 8 to 30 meters and major bridges span above 30 meters and long span bridges span above 120 meters. Next come to types of connection. Under this category, the steel bridges can be classified as pinned, connected, riveted or welded bridges. Next come to requirement of a ideal bridge. An ideal bridge meets the following requirements to fulfill the three criteria of efficiency, effectiveness, and equality. First, intended function with safety means it serves intended function with utmost safety and convenience. Next, it is aesthetically sound. Next, it is economical. The requirement of traffic aesthetic and economy for highway bridges shall be discussed in subsequent chapters. For the guidance of designer and ensure uniformity of practice, Indian Road Congress has evolved the following comprehensive and exhaustive codes. Highway Research Board of IRC has set up a committee for collecting information on bridges and dismantling knowledge through the preparation of state-of-art reports on selected bridges topics of importance. Highway Research Board has also identified areas of research on which there has been no unanimity of thinking and no uniformity in design methods. These areas cover the subjects like rational methods for evaluating scout depth, vibration in bridge decks, behavior of concrete in seawater. Next come to ideal bridge site characteristics. Suitable unyielding and non-erodible material for foundation should be available at a short depth for the abutment and piers of a bridge. The bearing strata should be free from tendency to slip or slide under sink loads and away from the fault zone. In other words, it should be geologically suitable. Next, the stream at a bridge side should be well defined and as narrow as possible. Next, there should be a straight reach of stream at bridge side. Next, should should the site should have firm and permanent straight and high banks. The flow of water in the stream at the bridge side should be in steady regime condition. It should be free from swirls and cross currents. Next, thus there should be no confluence of large tributaries in the vicinity of bridge site. Next, it should be realizable to have straight approach roads and square alignments, that is right angle crossing. Next, there should be no need for costly river training works in the vicinity of bridge site. Next, there should be minimum obstruction of natural waterway so as to have minimum afflux. Next, in order to achieve economy, there should be easy availability of labor, construction, materials and transport facilities in vicinity of bridge site. In order to have minimum foundation cost, the bridge site should be such that no excessive bridge work is to be carried inside the water. At the bridge site, it should be possible to provide the square and economical approaches. In the case of curved alignment, the bridge should not be on the curve, but preferably on the tangent, since otherwise there is a greater likelihood of accidents as well as an added centrifugal force which increase the load effect on the structure and will require modification of design. Next, there should be reasonable proximity to direct alignment of the road to shaft, that is, avoidance of long detour. Next, the bridge site should be such that adequate vertical height and waterway is available underneath the bridge for navigational use. Next, there should be no adverse environmental input. Next, come to bridge alignment. Depending upon the angle which the bridge makes with the axis of the river, the alignment can be of two types: square alignment and skew alignment. In square alignment, the bridge at right angle to the axis of the river. And in skew alignment, the bridge is at some angle to the axis of river, which is not right angle. As for feasible, it is always desirable to provide the square alignment. The skew alignment suffers from the following disadvantages. That is, a great skill is required for construction of skew bridges. Maintenance of such a bridge is also difficult. The water pressure on the piers in case of skew alignment is also excessive because non-uniform flow of water underneath the bridge superstructure. The foundation of skew bridge is more susceptible to scour action. At certain locations, to avoid costly and unsafe approaches, it becomes essential to provide skew alignments. In such locations, the following points are kept in mind. There should be smooth entry and exit of water underneath the skew bridge. The skew alignment should not be covered. It is difficult to construct and maintain the curved bridge. The curved bridge has to resist an additional force due to centrifugal action. It is always desirable to arrange the piers to the axis of river. Thank you very much.